Welcome back to Get Smart with Rory, once again bringing you Last Week in Science. Before we get into last week, I feel I should mention science of today, right now. Not only is today the winter solstice, it's also the date of the grand conjunction between Jupiter and Saturn. That is, in non-nerd speak, that in the night sky, Jupiter and Saturn are as close as they're going to be for the next 20 years. They're about 1/10 of a degree apart, which at arm's length is the thickness of a coin. If you want to see the event, look to the southwest early in the evening near the horizon. Basically, you should look for a crescent moon with two bright spots right next to it. Those bright spots might not look like two spots, it might be one spot, depending on how good your eyesight is. As said, it's the same distance apart as a thickness of a coin at arm's length. It's going to be pretty subtle. If you have a pair of good binoculars, of course you can see the difference more distinctly, and with a moderate telescope you might be able to see both planetary surfaces in the same frame. I'm expecting some really cool pictures to come out of this. Also, in astronomy news, we have the first potential radio signals that we've seen from an exoplanet. This radio signal is not, I repeat, not a sign of intelligent life. It's probably coming from a hot Jupiter, and hot Jupiters are, put simply, Jupiter or larger sized planets that are orbiting much closer to the sun, so they get really warm, and they have lots of gravitational field, and they're not terribly hospitable for life. But what this would mean, a radio wave detection from a planet outside of our solar system, indicates the presence of a magnetic field, and Earth's magnetic field, of course, is important in keeping the atmosphere shielded from solar winds, which allows us to have our thick atmosphere and therefore life. So if we can start measuring magnetic fields, radio waves from planets outside of our solar system, it's one more step in that search for hospitable planets. In stealth tech news, we have a new artificial chameleon skin modeled after octopus camouflage. This is a thermosensitive pigment that they've put into the suit, and in addition to being able to make a colored pattern to match the background, since it's thermal activated, they can also use it as a side benefit to become indetectable to an infrared sensor. So more cool camouflage stuff. I always kind of nerd out over the latest invisibility cloak. For pharmacies, we have the first clinical trials of DMT being used to treat depression in the UK. DMT being the psychoactive chemical that you find in ayahuasca, and it produces vivid hallucinations. I strongly encourage people not to do this on your own because you think of some anecdotal experiences that you've heard people say, but anecdotal evidence does say that people who've tried it often feel happier after the experience, long after the effects of DMT have abated. It will be interesting to see what this study comes up with. And finally, the big news, the news most important to me, I should say, is that the Chinese quantum computer Jiuzhang has been started. This the second quantum computer to claim to have achieved quantum supremacy, the first being Google's, which had a mere 53 quantum bits. This computer, according to their publications, is 10 billion times faster than Google's computer. To define quantum supremacy for people not in that field, quantum supremacy is when you make a quantum computer which is capable of doing something that could not be done flat out, basically, by a regular computer. Google did this by basically telling the quantum computer, hey, if I have this set up, what number would a quantum computer randomly generate? which is a little bit of a cheap shot because obviously they do the setup and the quantum computer figures it out. But nonetheless, they estimated that it would take 10,000 years for the best computers of the world to do the same process. Not technically impossible for a modern computer, but on such a large time frame that they said effectively that this is quantum supremacy. IBM challenges the fact. They say that their best computer could do it in 2.5 days, but the Google quantum computer did it in 3.5 minutes. So the difference in timescale is still rather staggering. If this new quantum computer is in fact 10 billion times faster, that's really quite incredible. And quantum computing is a complex field, put gently, but it solves some weird problems that normal computers can't ever figure out. Things where guessing large numbers and trying to figure out how they converge, it makes for complicated math, and normally we do approximations. One huge thing that quantum computers would be able to do very readily, which regular computers struggle with, is factoring large numbers. And why do we care about being able to factor large numbers? Well, all encryption data uses some product of 2 or 3 large primes. And the thing is, if you multiply 3 4-digit numbers together, then you get a 12-bit encryption, maybe 13 bits, depending on how the multiplication actually goes. But the point being, you get a fairly large number, and this is 12-bit encryption is a pretty small encryption these days. Even so, using a regular computer to figure out the prime factorization of this 12-digit number takes quite a significant amount of processing power. So being able to have a quantum computer just do it in seconds, if even that, is a huge step. And if a government, say, were able to get their hands on a quantum computer capable of doing 64-bit decryptions, then that would be something that they could use to decrypt any online data they wanted with very minimal processing power. And this is the reason why every government should be investing heavily, heavily into quantum computer science, because that's a major advantage to have over any country. And also why people should be perhaps a little skeptical when you hear how good a quantum computer is. Because on the one hand, every government is going to want to boast being that much closer to quantum computing because it's an intimidation factor. But on the other hand, if you have an ability to decrypt any online signal from other computers around the world, you might want to keep that secret, because so long as you have that and the other places don't know, you have access to data. But as soon as you broadcast that fact, people are going to become more cautious and not use the same types of encryption. They're going to start using encryptions which are harder for quantum computers to deal with. Very likely, governments are already starting to take this kind of thing into consideration. Anyway, quantum computing is a super deep dive that I don't really have time to get into right now, but that's the news from the last couple of weeks. If you enjoyed the show, as always, like, comment, consider subscribing so you never miss out, and until next time, see ya. By the way, I will be taking a week or 2 off for the holidays, New Year's. Expect a couple of videos, but I think Last Week in Science is going to probably not resume until January. Yeah. Have a good one, guys.